Hello friends, welcome to Learner's Planet. So this is our second theory session for the topic Is Matter Around Us Pure? In the previous session we discussed about matter, about what matter is composed of. We discussed about substances. We also discussed about the pure substance. Now this pure substance is further classified into elements and compounds. So we have already discussed about elements, the types of elements, that is the metals, non-metals and metalloids. In this session, we'll be discussing about the compounds. See, what are compounds? Right? See, we know that there are 118 elements existing in nature. But compounds are far more than the number of elements existing. So these elements, they combine and they form the compound. So we'll be discussing about the properties of compounds in this session. So let's start our session here, students. What is a compound? A compound is a substance made up of two or more elements chemically combined in a fixed proportion by mass. So a compound is formed by combination of two elements. Now those two elements are combined in fixed proportion by mass. Say for example water. Water is a compound and it is made up of what? Hydrogen and oxygen. And formula of water is H2O. Now what is the mass of hydrogen? It's 1. Mass of oxygen? It's 16. So how many atoms of hydrogen are present here in water? 2. So what will be the mass of hydrogen in water? It will be 2 and 16. So they are present in the ratio of 2:16, or I can also write it as 1:8. So in water, hydrogen and oxygen combine in a fixed ratio of 1:8 by mass. Likewise, we can take carbon dioxide. I had taken this example yesterday also, or in the previous session also. Say carbon dioxide. Mass of carbon is 12. Oxygen. Mass of oxygen in this. So mass of one oxygen atom is 16. Mass of two oxygen atoms will be 32. Now it will be 3:8 by mass. So carbon and oxygen are present in carbon dioxide in the ratio of 3:8 by mass. We can take another compound also. Say I'm taking NH3, ammonia. What is the mass of nitrogen? It is 14. What is the mass of hydrogen here? It's 3. So in ammonia, the nitrogen and hydrogen, they combine in a fixed ratio of 14:3 by mass. Now, this ratio will remain the same irrespective of the source. Say water, you can take water from anywhere. The proportion or the ratio of hydrogen to oxygen by mass will be 1:8 only. So this is how the compounds are formed. That is by the combination of elements in fixed ratio by mass. Right? Now let's discuss about the characteristics of compounds and also the classification of compounds, how they are classified further. Compounds. The compounds are classified into two types based on the source of origin. So depending upon where they are present or from where they are obtained. Now these are inorganic compounds and organic compounds. So compounds are classified on the basis of their origin as inorganic and organic compounds. Inorganic compounds. What are these? These compounds are obtained from non-living sources. Remember this. Non-living sources such as rocks and minerals. So the compounds which are obtained from these non-living sources like rocks, minerals, they are called as inorganic compounds. Even the compounds obtained from wood are organic because they are obtained from living sources. Wood was at one time living. right? So log of wood, that was at one time living. So the compounds which are obtained from non-living sources are known as what? Inorganic compounds. Say for example, common salt. Common salt, what is the formula of common salt? It is NaCl. That is what? Sodium chloride. The source is inorganic. This is obtained from non-living source. Marble. Marble is calcium carbonate. It is obtained from rock. Washing soda. Washing soda is Na2CO3 and it exists as 10H2O. So washing soda is also obtained from non-living source. Baking soda. Baking soda is NaHCO3, sodium bicarbonate. That is also a this inorganic compound. Carbon dioxide, ammonia, NH3, nitric acid, HNO3, hydrochloric acid, HCl. So these are all the compounds which are obtained from non-living sources. And so these are called as what? Inorganic compounds. Now there is one more category of compounds, that is organic compounds. What are these? Organ, as the word indicates, living, organism. So the compounds which are obtained from living organisms are called as what? Organic compounds. Let's take the examples also. Organic compounds. The organic compounds are the compounds obtained from living things. That is the plants and the animals. So the compounds which are obtained from plants and animals are called as what? Organic compounds. All the organic compounds contain carbon as their essential constituent. Do remember this thing. The inorganic compounds, this thing is not applicable to inorganic compounds. But all the organic compounds, they contain carbon as essential constituent. The organic compounds are quite often known as carbon compounds as they contain carbon. Right? As most of the organic compounds, I can say all of the organic compounds, they contain carbon as essential constituent. So these are also called as what? Carbon compounds. The examples are cooking gas, ethane, acetone, alcohol, acetic acid, sugar, protein, oil. Now let's quickly look at the formula of this. Say if I'm taking cooking gas. Cooking gas contains butane, or it's a mixture of alkanes. Right? Normally butane is there, N-butane. What is the formula of N-butane? You might not be knowing this, but I'm writing the formula just to tell you that carbon is present in organic compounds. This C4H10. This is what? Butane. Carbon is there. Ethane, it's C2H6. For you, there's no need to remember these formulae. I'm just telling so that you can know how carbon is present there. In all the organic compounds, the carbon is present. Acetone. Acetone is your nail enamel remover. That also contains carbon. See this. Alcohol, that is ethanol. It also contains carbon. Acetic acid. This also contains carbon. Sugar. It consists of glucose. And glucose contains chain of carbon atoms. Protein. Protein also contains carbon atoms. Fat also contains carbon atom. Or oil. So do remember, the organic compounds are the compounds obtained from living organisms, right? Like plants and animals. And that all the organic compounds contain carbon as their essential constituent. So these are often called as carbon compounds. So compounds on the basis of their origin can be classified into inorganic compounds and organic compounds. Inorganic compounds are the compounds obtained from inorganic sources like rocks, minerals, or inorganic sources you can say like non-living sources. Right? So non-living things. So the compounds obtained from non-living things are what? Inorganic compounds. And the compounds obtained from living things are what? Organic compounds. Now compounds are also classified based upon their characteristics. Or you can say compounds are also classified on the basis of their characteristics as acids, bases and salts. What are these? Acids, you all must be knowing, students, they are highly corrosive, right? See, if a sulfuric acid, if a drop of sulfuric acid just drops in your hand or anywhere, it burns. So these are like acids and bases, they both are corrosive in nature, right? Acids even give the burning sensation in eyes, right? So acids, see, a few examples of acids are sulfuric acid, hydrochloric acid, nitric acid, carbonic acid. If I write the formula, it's H2SO4 is sulfuric acid, HCl hydrochloric acid, HNO3 nitric acid, H2CO3 carbonic acid. Now one thing is common in these acids is hydrogen. Now when they get dissolved in water, say HCl, when it is dissolved in water, it gives out H plus ions and Cl minus ions. You don't have to go into this details. I'm just telling you for the sake of knowledge. That's it. So acids they give H plus ions in solutions. Whereas there are bases also. Bases like sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide. So what is the formula of sodium hydroxide? Sodium is NaOH. Potassium hydroxide, KOH. Calcium hydroxide, CaOH whole twice. Students, you don't need to remember this formula at present, right? Magnesium hydroxide, MgOH whole twice. So what is the thing which is common in bases? It is the presence of this OH ions. So bases they dissolve in water giving OH minus ions. You just remember this thing that acids they dissolve in water or acids give out H plus ions in solution, whereas bases give out OH minus ions in solution. Strong acid as well as strong base both are corrosive in nature. Now salts. Salts are generally formed by chemical combination of acids and bases dissolved in water. Salts are formed by chemical combination of acid and bases dissolved in water. See, sodium hydroxide plus hydrochloric acid in water will give sodium chloride, which is a salt, and water. So students, compounds they are formed by the combination of elements in a definite proportion by mass. Say the ratio by mass remains the same. Ratio by mass of what? Ratio by mass of the constituent elements in a compound remains the same irrespective of the source. And these compounds they are classified on the basis of their origin as organic and inorganic compounds. Inorganic compounds are obtained from non-living things. Organic compounds are obtained from living things or living beings or living organisms. Now, based upon their characteristic properties, they are classified into acids, bases and salts. Acids have hydrogen in common. All the acids have hydrogen, and when they are dissolved in water, they lose H plus ions. Bases have hydroxyl in common. When it is dissolved in water or when they are dissolved in water, they release OH minus ions. Salts are formed by the combination of acids and bases in water. Right? So this is sodium chloride is a salt, calcium nitrate is a salt, and zinc sulfate is also a salt. Now let's discuss about the characteristics of compounds. Characteristics of compounds. A pure compound is composed of the same elements irrespective of the source. See, the composition of a compound doesn't depend on the source. Say, in a compound, the same elements are always present in fixed ratio by mass, irrespective of the source. Say, for example, carbon dioxide. The two elements carbon and oxygen are present in the ratio of 3:8 by mass. Water. The elements hydrogen and oxygen are present in the ratio of 1:8 by mass. Likewise, I can take, say, hydrochloric acid, HCl. The mass of hydrogen is 1 and mass of chlorine is 35.5. So, hydrogen and chlorine in hydrochloric acid are present in the ratio of 1:35.5 by mass. So, irrespective of the source, a compound is composed of same elements combined in a fixed ratio. So this is another characteristic of compounds. The other is, a pure compound is homogeneous in nature. Homogeneous means it is uniform. A chemical compound, homogeneous, that is, it is uniform in nature. Say, if we select 2 or more samples of a pure compound and find the ratio of constituent elements, it remains the same. Say, we can take this compound from any source. We can collect, say, 10 samples. The composition and the ratio of the constituent element remains the same. So, a pure compound is homogeneous in nature. Its next property is, a chemical compound is formed by the chemical reaction between the constituent elements. A compound is actually formed by the reaction of the elements. Say, carbon, when burnt in air, forms carbon dioxide. Right? Say, hydrogen, I can take here as sodium. When reacts with chlorine, it forms sodium chloride. So, there is a chemical reaction taking place between the constituent elements in order to form compounds. Otherwise, compounds cannot be formed. Water, that is H2 plus O2. Hydrogen reacts with water, giving H2O. So, a compound is formed by the chemical reaction between the constituent elements. The next characteristic is, the properties of compounds are altogether different from the constituent elements. Say, I can take carbon and oxygen, the reaction which we took, CO2. Now here, students, carbon is solid, oxygen is a gas, and it is forming CO2 gas. Now here, carbon is solid, oxygen is a supporter, or it supports combustion. It is a supporter of fire. In the presence of oxygen, fire takes place, or fire, right? Fire requires oxygen. But carbon dioxide, it is not the supporter of combustion. Right? So, it is not combustible also. Likewise, water. Water is formed by the combination of hydrogen and oxygen. And it forms, right, like this. Now, hydrogen is combustible. Oxygen is a supporter of combustion. Right? But water is neither combustible nor a supporter of combustion. So, a compound has properties altogether different from constituent elements. We can take one more example, this nitrogen. No, not nitrogen, ammonia. Ammonia is formed by the chemical combination of nitrogen and hydrogen. Nitrogen is a gas, hydrogen is a gas. Ammonia exists in gas as well as in liquid state. You can say ammonia is a liquid. So its properties, its state is different. The properties of nitrogen and hydrogen are different, whereas the property of ammonia is different. So the property of the compounds are altogether different from the constituent elements. Let's take up the next characteristic. Constituents of chemical compounds cannot be separated by physical methods of separation. Physical methods of separation like evaporation, condensation, filtration, distillation, steam distillation. So these processes cannot separate the constituents of a compound. Water. We can't separate the constituent, that is, we can't separate hydrogen and oxygen by physical method of separation. Right? Say, if I'm taking elements, N2, nitrogen is an element. It cannot be separated into any other form of matter by physical as well as chemical method of separation. Right? And a compound cannot be separated into the into different constituents by physical methods of separation. Let's take one more example here. Say when the mixture of iron filings and sulfur powder is heated, a black compound known as iron sulfide is formed. Say iron filings plus sulfur powder. When it is heated, what is formed is iron sulfide. Heat. Now, this iron sulfide, iron cannot be separated by using magnet. Because iron sulfide has got altogether different properties from iron and sulfur. So, iron cannot be separated from iron sulfide. But say if I am taking the mixture of iron and sulfur powder. From here, from this mixture, we can separate iron by using magnet. Whereas we can't separate iron from iron sulfide by using magnet. Okay? So, the constituents of a compound cannot be separated by physical methods of separation. The next is energy is either released or absorbed during the preparation of a compound. When a compound is formed, energy is required. Say bonds are to be broken and bonds are to be formed. So the energy is either released or absorbed during the preparation of a compound. Say for example, hydrogen gas reacts with chlorine gas in the presence of sunlight, forming hydrogen chloride gas. That is, the hydrogen and chlorine, they are combining in the presence of sunlight. That is, they are utilizing the energy of sunlight. So when a compound is formed, energy is either released or it is absorbed. The composition of a compound is fixed. The constituents are present in fixed proportion by mass. This we know. So students, these are few characteristics of compounds. And one more important property, a compound has got a fixed melting and boiling point. A compound has fixed melting and boiling point. Got it? So these are the characteristics of compound. Now if there is a question like justify that water is a compound. How will you justify that water is a compound and it's a pure water, it's a pure substance? First point, that in water, hydrogen and oxygen combine in fixed ratio by mass. That is, what is the ratio of hydrogen and oxygen in water? It is 1:8 by mass, irrespective of the source. Secondly, the constituents or constituent elements cannot be separated by physical separation, right? Or separation by physical processes. Thirdly, water has got a fixed boiling point and melting point. What is the boiling point of water? 100 degrees centigrade. So at boiling point is affected by atmospheric pressure also. So you need to mention the pressure also. So at 1 atmospheric pressure. And one more point is there, that the properties of water are different from properties of hydrogen and oxygen. Hydrogen is combustible, oxygen is a supporter of combustion, but water is not. Water is often used as a fire extinguisher. So hence we can say that water is a compound. Likewise, students, you can be asked for any compound. Say you can be asked for carbon dioxide, for hydrochloric acid, for ammonia. So what you need to mention here is that the constituents combine in a fixed ratio of mass, fixed ratio by mass. Just take out the ratio of the constituent elements present by mass. Secondly, you have to write that the elements cannot be separated by physical process of separation. Right? They cannot be separated by physical process of separation. And third point, that the properties of the compound are different from that of the constituent element. That you can very well guess. And last, that they have got fixed boiling and the melting points. So these are the these are the characteristics of compounds. Right? I hope you have enjoyed this session. And in the next session, we'll be discussing about the impure substances. That is the mixtures. Mixtures are again classified into homogeneous and heterogeneous. So we'll be discussing about mixtures in our next session. Thank you, students, for listening patiently, and do have a nice time ahead.